Thank you all for joining us today. We are very happy to welcome Aaron Prather. Aaron is the Director of Robotics and Autonomous Systems Programs at ASTM International. He joined this organization a few years ago, and in his role, he oversees the creation of new standards he oversees the creation of new standards for robotics and autonomous systems, development of worker training, and various types of research and development. Aaron is regularly advising companies, academia, and government agencies on what robotics and autonomous systems can and cannot achieve under current technology conditions. With that, I'd like to introduce Aaron. And Aaron, the floor is yours. Thank you.
Thank you so much for having me. So, as mentioned, my name's Aaron Prather. I am with ASTM International, and I'm going to try and get my controls back here in a bit. Let's see. So, uh, a little bit just to round out my introduction. I'm the director of robotics and time systems at ASTM International, and as mentioned before, I work on standards development, R&D, and market analysis, and workforce development. Prior to joining ASTM, I worked for 25 years for a large logistics firm in Memphis that many of you are well aware of, where I worked on robotics, IT, and deployments throughout the network. I am listed as one of the U.S. experts to ISO for robot interoperability, and actually the photo you see there is actually a test we did here in Memphis several years ago of where we had a bunch of robots from different manufacturers actually work together through a new communication protocol that was developed that allowed those robots to talk to each other. And actually, the University of Memphis was actually one of the members of that test that actually made it all come together. I also work with the Arm Institute out of Pittsburgh on education and workforce development around robotics and autonomous systems. I work closely with our fellow standards groups at UL, ISO, ANSI. I work on several of their committees to make sure standards are being built, but also not conflicting with each other. And I've also, over the course of my career, have raked in a couple patents here and there in certain areas of automation and logistics. So a little bit about ASTM. We are one of the oldest standards organizations. We're based outside of Philadelphia. We actually last year celebrated our 125th anniversary, and we were born out of the railroad industry. The railroad industry was growing fast. It needed everyone to sort of be on the same page so we could actually build a coast-to-coast network of trains, and there had to be certain standards so trains could do that and actually go anywhere the tracks allowed them to go. So ASTM actually was born out of the railroad industry to help set their standards. Now we are in pretty much every industry there is on this planet. We have published over 12,700 standards globally. We will probably this year cross 13,000 standards in various industries. We also look at different disciplines. We are not bound just here in North America. Our standards are used everywhere across the globe. They are sometimes referenced in trade agreements between countries to make sure, again, that certain standards are being met regardless of what country the business is coming out of. Certain standards are met so a global economy could be built. We work with manufacturers. We work with material scientists. We do everything and anything, and we'll touch on some of those here in a little bit. And my focus is on the robotics side. But just before we fully close out, just again, ASTM standards are everywhere. We're big in construction. Those are just a couple of the construction standards that are used. We've been able actually to create standards for additive construction now, where you can actually 3D print a home because there are global standards now that exist that allow that to happen. We're very big in consumer products. Sometimes I have better luck of explaining ASTM International to mothers because they see our logo on toys and cribs and high chairs on numerous consumer product uh, items. ASTM helps set the standards for those types of products. We've also helped in new industries like the cannabis industry actually build their first group of standards so that they can show regulatory agencies, not only here in the United States, but in other countries, that they are doing uh, they're making their products through a standard, through an accepted practice that others are using to make sure the product is safe. They know how to test the product, and the tests can be duplicated. So we actually have given the cannabis industry a big leg up with regulatory agencies because they're able now to show that they have done their work of how to make a quality product, a safe product, how to measure and benchmark, because they've built those standards through a standards organization like ASTM. And then another one that we're really proud of is we actually have set a lot of the standards for commercial space flights. Actually, this is a picture of Michael Lopez Algier, who is the chairman of one of our committees that sets the standards for commercial space flights. And this is actually him up on the space station, and he actually conducted a committee meeting from the International Space Station to make sure that they got the votes and consensus built around a certain standard for spacecraft. He ran that from the space station. So standards are everywhere, not only on the planet, but now up in space as well. So we're not alone in this. ASTM is one of many standards development organizations, or SDOs as we call themselves. The big ones, of course, are the ones you know: ISO, ANSI, UL, IEEE, but the list goes on. We're the bigger players because we're more on a global scale. We cover numerous industries. There are some standards organizations that focus strictly on a specific industry, and that's fine. Sometimes those are some of the strongest standards groups because they are so hyper focused into their industry. But global standards groups like ASTM, like ISO, like UL, we make sure that global trade, global businesses can be done because we help set the standards then that are agreed to by people from across the globe. And that's what the beauty of standards is they are consensus-based standards that a vast majority, if not almost everybody, depending on how the standard has to be voted on, agree that that is what they want to be held to as their standard. One key act that happened here in the United States that is very important is the National Technology Transfer and Advancement Act. This was signed back in 1996, so during the Clinton administration. But this act really opened up markets by helping speed up what are those technology transfers that are needed to speed products to market. They very much helped open up the federal laboratories at NIST and other locations to help speed up research that will help the businesses get product to market faster. But one of the key aspects that's in that act is the requirement that regulatory agencies first look to see, is there a consensus built standard that the industry that the regulatory agency is looking at has already accepted, has their members are saying, this is the standard we want to be held to. And this has actually helped regulatory agencies not reinvent the wheel or create a regulation that makes no sense to the industry that's being regulated. Standards that are written by the actual industry and consensus agreed to. So everybody, all the competitors within that industry agree that this is what they want to be held to, makes it much easier for a regulatory agency to come in saying, okay, if that is what you want to be held to, we will then enforce your standard. So this is what this act actually opened up. And I put the actual text of importance that's in the act that pretty much contain that the standards may be used as the starting point for writing a regulation, or legislators may also use standards as purely advisory guidelines, or may refrain from the regulation in a given area because the voluntary standard is accurate. So a standard, if it exists, may be enforced automatically. A regulation may use that as the seed for the regulation or the law that comes after it, or the law body could come down saying, okay, the standard's there, let's build from there. So it goes all the way up and down the chain from laws, regulations, and standards. And that's what this slide's all about, is when we look at how we govern our lives. Laws are at the top. A law applies to anybody and everybody. It comes out of a legislative body. It is signed by a ranking member, a governor, a president, somebody. That is a law. And we've all done our schoolhouse rock. We all know what that is. But then what's a regulation? Well, a regulation is something that is decided by a regulatory body that might have been created by a law to do certain things, and they come up with the rules, the administrative laws. They do carry the force of law in many cases where you can actually be taken to court for violating a regulation. You can be fined for that, and sometimes in other cases, even worse things can happen. But a regulation comes from a non-elected body, but gets its power from that elected body. So then where does standards fit in this? Well, the standards are coming from SDOs like ASTM and ISO or other organizations. Even industry trade groups can come up with standards, as long as they're go through a mechanism that shows that they were voted on, they were agreed to, they came out of consensus, and it wasn't just one company's idea. So that's the biggest key. So the standards are at that bottom, and there's a lot more standards than there are regulations, and there's more regulations than there are laws. But this is the pyramid of how things can move up and down the chain. And the photo is actually of the Robotics Industry Association, the RIA, which has recently rebranded themselves as A3, the Association for Advancing Automation, where they actually signed a partnership with OSHA and NIOSH on robot safety standards, where RIA, now A3, helps develop robot safety standards through an ANSI agreement that then now, as those get published and voted on and agreed to, OSHA can then say, we like this standard and we're going to enforce this standard. And they can do it under what's called the general duty clause of OSHA. So they can actually say, if there is an accident where a robot injured a human due to some safety issue, they can actually cite a robot safety standard that the company should have been following, and they can fine them under the general duty clause of OSHA. So this is why knowing your standards in your industry are very key, because there might be a regulatory agency further up the stream that's going to enforce that standard under their preview. So again, standards are everywhere. And after this presentation, a lot of you might really start paying attention to some of the products around you, looking for these standards marks. ASTM, we do a lot of safety toe footwear tests. So if you wear steel toes or the composite toe shoes, there's an actual ASTM test that shoe can go through. And if it passes that test, the maker of that shoe can put in that they tested this to ASTM F2413 for safety toes footwear. If you look at all your electronics, you're going to see the UL symbol on that, meaning UL has tested that piece of electronics against one of their standards. UL was born out of the Great Chicago World Fair fire, where they showed off the power of electricity and lighting, and then the whole place caught on fire and burned down. The founder of UL is like, we probably should have standards around electrical safety, and therefore UL was born. And it's just amazing of what they cover now. And if we think about everything in our life that is powered by electricity, UL standards are helping keeping us safe. And we all know about ISO. 9001 is one of those big ones that every company wants to get certified to, saying that they are a quality management. That is what ISO 9001 is. It is a quality management standard that shows that you have processes and procedures in place within your business that produces quality management results. And you actually have to go through an audit to get that to the standard, to show that you are in compliance with that standard. So again, standards help us advance business, help advance product, and also tell consumers that the product has been tested against something and is safe. So when it comes to robotics, as robotics have taken off, there's always been the talk about the three laws of robotics, and this came out of Isaac Asimov's great book Runaround back in 1942, and it actually showed itself back up in other books by Isaac Asimov, I, Robot being the most popular one, where they laid out these three laws in this fictional book called the Handbook of Robotics, the 56th edition that was published in 2058 AD. So oddly, many of us might actually come to 2058 AD and wonder where this handbook is. The great thing is there's a tons of standards that really create what these laws have been. And just to give everyone a heads up of what the laws were, if you do not know what they are, the first law pretty much says a robot may not injure a human being or through inaction allow a human being to come to harm. So, sorry, the Terminator should not happen under the three laws of robotics. The second law is if a robot is given an order by a human, it can't be in conflict with the first one. So, a human can't tell a robot to kill another human being. So again, the Terminator is not really there. This, though, makes a lot of questions now about the growing use of robots in warfare. So we might already be in violation of the three laws already. And then the final law is a robot must protect its existence as long as it protects, does not conflict with the first or second. So that means a robot should not let any harm fall onto it unless if it does not allow harm to fall on it, that harm falls on a human, then there's a problem. Recently, there was a lot of talk about arming police robots with bombs or guns to take out folks. There was a lot of arguments around that is allowed under this, that a robot to save a human's life would allow itself to be destroyed in the process to save the human. That's sort of what was being argued. Again, these are great thought exercises. The practicality of them in our modern world is a little harder, but as a person that writes standards, we always think about this, and we focus on the first law of a robot should never hurt somebody, and that is where the vast majority of our minds are, and we try and we'll come to the military and police robots down the road, but in general, the main thing is a robot should never hurt a human. And there is actually a standard that calls that out, and that is ISO 10218. And this is the top of the pyramid when it comes to robot safety standards. This is the one that everyone looks up to. This is the one that governs everyone. It's been around the longest, and it really does ensure that we have safe robot installs. And when you look at the industry, there's only been a few handfuls of deaths involving a robot and a human, and the vast majority of those have fallen through some of the cracks or gaps that have been identified in these standards, and we do work to fill those gaps as we learn on that. And just to give you a history on ISO 10218, it is actually broken into two parts. Part one is focused strictly on the person making the robot, what they should follow, what safety features should they put in the robot itself to make sure that it can operate safely. Part two is is directed to the integrator of the robot system. So now the integrator is going to take that one robot that has already gone through part one of the standard and is going to put it in a larger application. So part one only addresses the robot itself. Sometimes it doesn't even address the end effector or anything else. It's just the robot itself. But if I'm going to make that robot now build pallets of boxes, what kind of fencing do I need? Do I need light curtains? What's my end effector going to look like? How fast should I be operating? That's all addressed in part two, because now you're building an application. You're building a larger system out. So in Europe, this ISO 10218 lines up perfectly with its EN designation, and it aligns with the machine directive in the European Union. Here in the US, it aligns with ANSI RIA 15.06. So here in the US, you would say you follow our ANSI 15.06, but it's really you are following ISO 10218 at the same time because they are interlocked with each other. This committee, the ISO TC 299 committee, is who's in charge of developing 10218 out. I am a member of that as part of the U.S. delegation. So, and right now we are in the process of probably one of the biggest updates to this standard ever. The last published one of it was back in 2011. There has been a lot of changes in robotics since 2011, to say the least. We kept up with those changes by adding little add-on standards that would address some of the gaps as some of the new technologies came out. But now here in 2024, we're actually taking all those smaller standards and putting them into 10218. So 10218 is going to go from about 100 plus pages from when it was published in 2011 to over 200 pages, just to address some of these newer robot technologies that have come out since, like collaborative robots, various vision systems are being addressed. All that is going in. And so the reason the standard is actually getting bigger is just to address more of the technologies that have come out. We're hoping to publish that this year, this summer. But this is the main standard that everyone holds their robots to, is ISO 10218. So when, as I mentioned earlier, 10218 is broken up into two parts. First one is the manufacturers and the integrators. And there are three groups when we talk about robot safety. The manufacturer is a big one. Who makes the robot? Are you making a safe robot? Does it have safety features built into it? If not, what are the other types of ways to keep it safe? The integrators are the ones that then put the robot into an application like a welding one. But the third group that ISO 10218 does not address are the end users, the actual companies of how are they using that robot? What is their responsibility? Because as soon as a robot is installed and the integrator is done, they're done with their job. So now the safety really falls on the end user. And there's a lot of work taking place now to address some of the gaps that have been missing from the manufacturers or integrators part of the process to the end users. Because if an end user changes a feature of a robot cell, what are they? Are they still the end user, or are they now taking on the role of the integrator? And that's why I put that line down there at the bottom. Some companies might actually jump between these groups in their robot journey. There are some companies like Amazon that actually make their own robots. So they are actually their own robot manufacturer. They also then take that robot that they built themselves and they integrate it into their warehouses. So they're now the integrator. But then the day-to-day operations at Amazon, they're the end users using those robots. So what are the three different rules that apply to each of these three groups can sometimes get tricky. And that's where standards organizations like mine are trying to address where some of these gaps are in each of these different types of groups and who has what. Because we're trying to make sure we keep the safety high, because this industry, as I mentioned earlier, has not had that many deaths. Depending on how they're categorized, but since 1980, there's only been about 20 to 40 deaths by robot. Again, that's a range, a bit sort of a big range, because it's almost double from the 20 to the 40. But it's how do you classify some of these is what's made it tricky. I'll say 40 is a high number, but it's not a terrible number compared to other industries. And one of the reasons why is the robotics industry takes safety very critically. As I said, 10218 has been around a long time, and it's because they want to make sure that there is a global standard that everybody can follow when it comes to robot safety. So what does each of the standards groups do to address these? ISO is focused mostly on safety. They do some test of performance, but ISO's also main focus is advancing the marketplace, getting robots faster out to the market, but in a safe manner. UL focuses on safety, but more from an electrical fire prevention perspective. ANSI here in North America focuses on application safety and is ensuring that North America is aligned with the other key standards at ISO or ASTM, especially in terms of general machine safety. ANSI has probably some of the best general machinery safety standards in the world, and some of those have actually become ISO or ASTM standards themselves. And then finally, my group, ASTM International, we do safety, but when it comes to robotics, that ISO's done such a great job of focusing on robot safety. We're focused more on test performance standards and how do they support the larger groups. A lot of our standards are actually baseline standards for some of the other groups. Case in point, we do a lot of the electrical connection standards of making sure there's no sparks. UL leverages those into bigger standards to make sure that those sparks don't become fires. So they leverage a lot of our very baseline standards into their bigger standards to ensure it doesn't become a bigger problem if you're following those core standards. So what does an SDO committee do? I'll use ours at ASTM International. F45 is our robotics committee. A committee has to have what is their scope? What are they tasked with? F45 actually initially was kicked off as an autonomous vehicle committee, but then it quickly realized it wanted to do a lot more stuff in industrial robotics automation. So it expanded its scope. So that's the first thing any committee has to have is what is your scope? What are you allowed to work on? What are you not allowed to work on? So F45 has very much said that any kind of automated autonomous vehicle, they can definitely address. They can address robotic arms, manipulators, and the sensors used in those systems. They can look at smart infrastructure that supports the robot or the autonomous system, and they're not confined to industries. They're anywhere, advanced manufacturing, logistics, or any other type of automation. So this is just a couple of the types of tests that they have been working on. They've been working on navigation tests. They've been working on pick and place types of applications. How do you pull cloth? What does that look? How do you detect certain things are some of their standards. As I stated earlier, they were established initially as a driverless automatic guided vehicle group back in 2014. They have definitely pivoted where they cover a lot more. They have 11 approved standards that have been published. They are currently working on 14 more new standards. That's how fast the industry is growing, that they've already identified 14 new work items that they have to get through. They have broken themselves into subcommittees that focus on very specific areas. One works on environmental conditions around the robot. Another one works on docking and navigation for the robot. Object detection and protection is another subcommittee. System communications and interoperability is another team on the committee. Grasping and manipulation is another group. The latest one is a legged robot. We've seen a fast rise in legged robots. And so this group has come together under F45 that works strictly on just robots that have legs. What are the safety around them? How do you test them? How do you make sure they don't fall over? That's what that group works on. Each of these committees meets monthly virtually, but they also come together twice every year for in-person meetings where they actually sit down and go over various items. They look at the tests that are being developed, the standards that are coming out of those tests. What do those look like? Again, just some more videos of just various things that they are working on. The grasping and manipulation team has gotten very busy recently on just working on grasping strength. And there in our corner is one of the first tests for legged robots to determine stability. And yes, all they did is they took a very fancy treadmill and put a robot on it to make sure, can he stay stable as it moves up and down, if it starts moving, the treadmill starts moving, how will it adapt? We're trying to find what is the stability of the robot. So what are some of the types of standards you might come across? And most standards fall into one of these 6 buckets. Either they're a test method, they're a practice, they're a specification, they're a classification, they're a guide, or a terminology. What does that mean? Well, a test method is pretty straightforward. You come up with a test, you measure it, you show the results. So case in point, your robot arm is fully extended. Now measure, what does that full extension look like? So if you say your robot can reach 8 feet, when I fully extend it, it should reach 8 feet. This should be a very pass-fail test. You'd be amazed how many fail that test based off of what they're saying, what their robot can do, it can't do. This is why we do these tests, to prove that you either you have that capability or you don't have that capability. Practice. This is how would you measure the standard? How do you actually conduct the standard? So here, we would actually lay out in a standard of its own how to set up the test, of how will you do the test, and it literally just goes through all the various setups, looking at lighting, temperature, humidity, so you can make sure that your test can be duplicated by somebody else by following this practice. Specification standards. Either it meets the spec or it doesn't meet the spec. So if you're saying your robot can reach 23 meters long, it either is in the spec or it is not out of the spec. This is to help, these kind of ones help determine what kind of parts normally go into a robot. So if you have a robot that needs to have certain capabilities to go fast, but also stop quickly, we would have a specification for your vision and braking systems to determine, okay, if you want to go that fast, you would look at this specification test to determine what sensor you need to give you that speed, but also the safety of you stopping in a timely manner. Classification, very simple, of like, is your robot small, medium, or large? Well, what sets those parameters? This is the type of classification. We're seeing a lot of commonality now with marine robots starting to get into classification standards, because if you have a marine robot, first thing you need to know is how deep can your marine robot dive? Is it only rated to 50 meters of depth or 100 meters of depth? So this is a new type of classification that we're having to set standards for, so consumers know what if they have a specific use case, which robot will fit into that use case based off of classification. Guides is just how do you do some of these types of tests. If we call for a measurement test, we might actually specifically have to say how you will measure it. Here's just an example. Each one of these 3 rulers will give you a measurement of distance, but you might have to get down to a very specific number, so we might recommend a specific ruler on here because of the accuracy level you need to get down to. So it's a guide, we'd put that in there. You need this specific piece of equipment to do this measurement. That would be in the guide. And then terminology. Terminology is key because we all have to be talking a common language. So what is an end effector? What is an origin point? What is a manipulator? So we actually have a terminology guide, and it's sometimes the most, out of all the standards that we have to maintain that can get very tricky very fast, is a terminology standard, because we want to make sure we're using the same terms across the board, across each country. So when we say what an end effector is, everyone knows what we're talking about. Because if you don't define your terminology, all your other standards could go sideways very quickly because you did not define a term. And if someone else thinks that term means something else, it totally throws off the rest of the tests. So some examples, this is from our object in detection. They actually made a guide of test objects. These are various objects you should have your mobile robot be tested against, make sure that they can detect it. You'd be surprised how some of these objects throw robots for a loop because they just can't see certain things. Ladders are the biggest one. And trust me, if you're working in a warehouse, you want those robots to know if it can detect a ladder, because there's so many around there. Same thing with forklift signs. I've seen numerous robots in warehouses run into forklift signs because they just couldn't see them. Well, test your robot against those in a test artifact kit. And we've actually written a list of various objects that you should test your robot against, and you can just go buy our guide and go get those items. And we try and make sure that every item we put in our guides can easily be obtained at either a Home Depot or Lowe's or a Walmart. So we don't go asking for very high-end stuff. Then after you have your those obstacles, then we'll show you a test methodology of how to set up your test for your mobile robot. So if you build a maze, and I'll show you the maze here in a bit, where do you put the chair? Where do you put the ladder? Can you create as many real world examples to test your robot against so that you can actually show that your robot can detect those and avoid those items and therefore should operate safely in your environments because they won't run into them. So then, now that we've done that, here's the test. So we actually then give you the test methodology to navigate in a defined space. And this is one of the robots. You see, we put a crate there. He has to detect it, make sure he gets around it. But we set all this up based off of the earlier two standards we just talked about. And then finally, we'll even take it another step of, okay, not only can the robot navigate and avoid that, but here we want it to actually dock in a very specific area so it can charge itself. So in the first test, we're showing that it can avoid certain things. Now we want it to actually find something and get up to it and actually do something with it. And in this case, charge. So the whole thing is we've set up a test to show what artifacts you should put in your test, how to set up the test, what the test will look like and how to record the results, and now how to actually do something completely opposite in the test to show that you can also do that. That's the kinds of things robot manufacturers, integrators, and end users want to see in their robots. They want to actually see that their robots can do these things or not do these things and document it all. And the standard allows them to do that. And then our grasping robot test is another one. Here we're actually taking years of research from NIST, where we're actually having the robot grasp this test artifact that actually has measurable nodes in it, so it can actually measure the strength of the grasp. Because if you're an end user, if you're a FedEx, an Amazon, and you want to buy a grasper, you want to ensure that it has enough strength to actually hold on to something, but not too much strength that it crushes it. So this is something, again, another test that the marketplace has asked for of show me the exact strength your end effector has in grasping, because I want to make sure it can actually pick up what I want it to pick up, but I also don't want it to damage it at the same time. This is a standard test that you can actually do using this artifact, this test artifact that with these measurable devices inside of it. And you can do this on your own, or you can hire a lab to perform the test for you if you want them to. So the whole thing is going forward, regardless of what standards organization you're looking at, after you publish a standard, you're always going to ask the following questions. What are we still missing? What is the most important or least important thing we should address next? Are there still gaps even after we've published the standard? And what areas aren't covered? So you're always constantly looking for what's the next thing we have to update? What's the new technology we have to address? So our work is never done. But if based on some of these core standards, as I said, 10218 has been around a long time. It just keeps getting updated as the technology gets better. That happens with every standard. At ASTM, a standard lives for 5 years. As soon as its fifth year is done, it enters an area of review. If it needs to be updated, or it just needs to be reapproved because nothing has changed. But if no vote or no continue on as is done by the 7th year, it is taken off the books. So that's how we ensure no bad standards stay on our docs. Is after 5 years it enters review, it either gets updated or just, hey, the standard's still solid, nothing has changed, reapprove it, it goes back in. If that is not done by the 7th year, the standard gets kicked out and is gone. So this is how we make sure we stay up to date on certain things. So what is coming? It is very clear that we have to have end user standards, and ANSI and A3 are already developing what is going to be called the Part 3s. As I mentioned earlier, ISO 10218 is 2 parts. Part 1 is the manufacturer, Part 2 is the integrator. These new Part 3s are going to be very focused on end users and what is their responsibility after the integrator has installed it, made sure it's worked, handed over the keys, they're now done. What is the ongoing responsibilities of the end users to maintain that system. So that is being worked on now. They're going to actually write 2 part 3s. One will focus on robotic arms. That will fall under R15.06 with ANSI and A3. And then R15.08 for mobile robots will have a part 3 for its end users. This will create an enforcement pathway for OSHA. So this new standard will be something that OSHA will be able to use if they have an incident with a robot and a human at a work site. They'll be able to go look at this part 3 and ask the end user, why weren't you following part 3? And so it's going to be very critical that everyone makes sure that they're up to date on these standards, because a regulatory agency like OSHA can and will use it for enforcement purposes. The other area that we're seeing a lot of growth in is in application and tech specific. As I stated earlier, ASTM has just founded a legged robot group that focuses specifically on legged robots, because legged robots are one of the fastest growing segments of robotics right now. So they are very much working on that. The first one that they are working on is a stability test to ensure that a legged robot can stay stable and does not fall over onto somebody. So it is a technical test to test the mechanics of the robot to ensure it doesn't tip over, with the drive of this will be safe, make it safe for the robot to be around humans because it won't tip. So that's what they're working on. But we're seeing other industries, nuclear, agriculture, healthcare, are all saying that their specific environments require new standards for robots because they are so different from what robots have ever handled before. It's time to develop standards specifically for their industry around robots. So that's another area that is growing very fast. And then finally, there's going to be more alignment with regulatory agencies. As I mentioned earlier, ANSI and A3 have an alliance with OSHA. The Consumer Product Safety Commission and ASTM have a very strong relationship. This is going to just continue. You're going to see more regulatory agencies and SDOs partner up together to address issues faster through the standards making process, so the regulatory agencies can get consensus through the industries, then through the act that we talked about, and then enforce it. It's faster to go through the standards organizations than versus the regulatory agency itself. So we're going to see more SDOs and regulatory agencies work closer together. So what's already on the schedule? OSHA inspectors are going through robotics training. They are being trained on the standards that are pertinent to them and the industries that they cover. So another big thing for those business owners that might be on the call, you might want to make sure you're up to speed on the robot safety standards, because the last thing you want is an OSHA inspector knowing more about robot safety than you do. So if you are putting robots into your environment, I highly recommend you start getting up to speed on all the robot safety and performance standards that the OSHA inspectors are being trained on. And quite frankly, right now, they are already over 50% done with most of the inspectors as is. This year, they'll finish up. So every OSHA inspector by the end of 2024 should have gone through their training. The new grasping standards that we're working on will be published this year. Those are based off about 5 years of research at NIST, and we're publishing both fixed mobile robot standards, so as pictured here, a robotic arm grasping something, but we're also going to publish some standards from mobile robots that can actually move through a space and grab something and take it somewhere else. So there will be standards on that as well published this year. So a lot of more standards are coming out around robots that can actually grasp things and pick them up. How strong can they do that? How weakly can they do that? How accurately can they do that? All that's going to be shown through these standards. And then finally, the federal government is going to start leveraging some of the standards around autonomous trucks that have been developed by numerous SDOs. SAE is a big one. And there will be federal rules coming down the pipe this summer around autonomous trucks. And those are based off of standards that have already been developed. They are moving up the chain to the regulatory phase. So how, in closing, how in all this talk can you get involved? How can you actually participate in the standards making thing? Well, the first one is join a committee. We're all of us SDOs are always looking for new members to join. The only caveat we ask for is that you participate and you vote, because we have to have consensus. So joining a committee and not doing any work is bad. Joining a committee and then not voting is the worst thing you can do. So if you want to be part of the process, we will welcome you with open arms. We expect though you to contribute and to definitely vote. And you are allowed to just not vote, but abstain. That's fine. All of us would rather you abstain than not vote at all, because abstaining at least counts in the totals. So if you are really wanting to do standards work, go find the organization that's best for you. Be that ASTM, I will gladly take anyone that wants to work on our standards. ISO would gladly take anyone. ANSI, A3, the list goes on and on. All we ask for is that you participate and you vote. You actually are a productive member. And if that's the case, we will love to have you. The other one is if you're a researcher. Have you ever thought about your research actually supporting a standard? And we call this R2S, research to standards. It is probably one of the best things I think a researcher could actually do. And we fully understand publish or die, but how many standards is your research backing up? How is your research supporting the standards regulatory framework and making it better? That can be gold. And I can say that the ISO 10218 was leaning heavily on a lot of German research about struck by and strength tests on robots. They're shifting that to research that came out of Korea that was better, more up to date. And so the new 10218 is going to actually now reference new, better research that has come out over the years out of Korea. And they'll be the one referenced in the new standard going forward. Who's to say who's the next group up? So if you're a researcher, getting your research to support a standard is gold. And NIST actually has recognized this, and now they are making it a mandate that 50% of their researchers' work has to go and support a standard somewhere in some industry, not just robotics, any industry. So if you're a researcher, I would say, how many standards have you published? Not how many papers have you published, how many standards has your work actually contributed to society? That would be my next question. Another area that is starting to open up is student chapters. Professors that are working on standards, a lot of them have built their own student chapters where the students get to be exposed to standards, and some of them even write standards while they're still students. And they base it off the research that they're doing, and they're bringing it into standards world. This photo right here is actually at the University of Central Lancaster in the UK, and this is a student chapter for exoskeleton standards development. And not only have they contributed, this group will actually have their first published exoskeleton test standard. I believe it's on an elbow test. And that will come from the students. And that's something they'll be able to put on their resume for the rest of their life. That they as students helped develop a standard for exoskeletons. And then the last one is conferences and meetups. The International Robot Safety Conference is held every year. I believe this year it's going to be held in Cincinnati. That is where you'll hear about all the new safety standards, how to apply them. And if you want to help write them, you can join right there. The International Conference on Advanced Manufacturing develops standards from additive manufacturing, construction, robotics. So those conferences are there for not only to learn about what's coming down the pipeline, what the new standard does, but it also gives you an opportunity to join those committees and actually contribute to them. And with that, 8 minutes left. Again, if you are interested in joining standards work, even if it's not with the ASTM, feel free to reach out to me. I will gladly put you in contact with any of the other SDOs for your whatever focus area you want to work on. But I really highly recommend, if you really want to impact day-to-day life or move products forward, get into standards making. It sometimes seems boring. It's not the most sexy thing, but it does move the needle forward for everybody. Thank you.
Well, Aaron, thank you. That was a lot of information,
Yeah.
and it was very well packed, but very equally informative and concise. We're going to open the floor now up to any questions that anyone may have. I know that there was one question from our good friend Kevin Burisso, Dr. Burisso, who asked how, as an educator, can he become more actively involved in the standards process? But I think you just kind of answered it with your last slide there, saying, with the meetups, with the conferences, things like that, just getting more involved and getting your student body more involved in that, things like that,
Yep.
with chapters and things like that. Correct?
And to give credit to Dr. Burisso, he has actually invited me to some of his senior classes where I have sat down with his students, and we've covered a couple of the standards of just how it goes into it. It is probably a great intro to standards that way.
Right. I think you've done the same with Stephanie Ivy's group as well. I
Mhm.
know for those who are local or not local, she runs runs the West Tennessee STEM Hub organization. I know you've spoken a number of times. I don't want to say how many. I don't know off the top of my head.
Mhm.
But you've spoken a number of times to her students and her organization within her under her purview. So
Yep. I mean, it really comes down to, if you are a professor and you'd like to get your students involved in standards, first question is going to be, are you involved in standards?
that's the first thing. That's a great point. Yeah, it's like,
Yep.
how involved are you in the standards? Yeah,
I mean,
yeah,
the University of Central Lancaster, the professors there have been involved in standards for a long time.
right.
So it was just a natural progression to get their students involved. So
That's true too.
it is a step-by-step process, but it is a great way, because that's actually one of the big questions we've always asked in the standards is, how do we get young folks involved faster?
I guess that also goes across the board, not just within standards or anywhere within, let's say, even engineering. I mean, that's at a university at whole. How do we get more involved? How do we get more student involvement? Things like that. And this is a great way because, like you said, it sets you up for the future. This is,
Mhm.
we've seen it now with robotics and even mass producing robots like Boston Scientific, all the videos that they've been doing, right? And then how does
Yep.
AI play into all of this?
Yep.
Um,
And AI is the next big one. And
yeah,
everyone's trying to figure out, how do we write standards for AI?
yeah,
There are some efforts underway in small areas, but that's a huge opportunity. If you're really intrigued by AI, if and you're like, I should probably be involved in standards, this is the time to get in, because everyone's trying to figure out where even to start when it comes to AI.
for sure,
So
for
so
sure.
there are so many new opportunities always opening up. But if you're a researcher and you have some solid research that backs up things, that is what us standards organizations love.
Yeah,
That's like, wow, they've already proven this. So it's like, why not make it a standard? So
yeah,
it's a way to really get some of your research out there much faster, because I'm sorry to say, I mean, I have had to deal with some people in academia that they're like, oh, well, I'm fine. People can just cite my research and say they're in compliance with my research. It's like, nobody goes that way. No one's going to say, follow Dr. Smith's research over here, and if you comply with his research, we're okay. No,
right.
they're going to be asking, are you in compliance with ISO whatever, ASTM whatever, UL whatever? That's what
Yeah.
they're going to ask for.
That's a great point. It takes, like you said, it takes a little bit of flexibility in that regard to just be up to date on those standards. I do have one question.
Mhm.
You mentioned that some of the members, I think it was of IEEE or I can't recall exactly who a member was, but someone on the who was running one of the committees was on the International Space Station
Mhm.
and ran a meeting from the International Space Station. How logistically did that work? I'm very curious about that.
I mean, the good thing is it was NASA's phone, so that helped. Um, and they were also nice not to give us the bill, which was very nice as well. it was a logistical challenge to say the least. But it was only 15 minutes. But in that 15 minutes, I think he went around the planet like twice, maybe even 3 times. So, but
Is there a time zone that you're, I mean, is it like, okay, everyone just join at 8
Mhm.
o'clock, PM Central or something, and this guy's like, it's,
Yep.
I'm just on a, on a 16-hour schedule and then I go to sleep for 8 hours type of thing, or is it, are they on, so how does that work?
I mean, that's sometimes the big challenge when it comes to some of these standards groups, especially when you're a global, finding the right time to get that. Within ASTM, we try and pivot back and forth where we'll have an early morning call where it's afternoon for Europe, and yeah, it's the middle of night for Asia, but
Right,
the next time we then switch it, we do an afternoon call. So then it's morning in Asia. Yeah, Europe, now you're in the middle of the night.
right.
And so we try and be cognizant of the time difference. And it is the dark side of standards making. Sometimes
Yeah, and that's true. I think that's true around, I've had those meetings too where, you're dealing with, and being respectful for our friends and for those colleagues that you have in Asia, wherever they may be, right? And
Mhm.
you're going, okay, I'll take a call at 10 o'clock at night, because it's good for them, it's early morning for them, and then vice versa, and they repay that favor. So
Yep. Yep.
I know we're almost out of time. Looks like we have one question. I think Kevin was asking how often do the committees meet? I guess those are ASTM committees.
Yep. For ASTM, they meet once a month virtually, and then they meet twice in person. And actually, the first in-person meeting for this year's coming up for them in April. I believe it's April 10th in Philadelphia is where they're going to meet. They'll meet again in November. This year they're going to be in Orlando, so they were super excited about they're going to Orlando for those meetings. And also they sometimes schedule their in persons with another committee so that they can exchange ideas. So sometimes they'll meet with the F-48 committee on exoskeletons because they're trying to figure out where do wearable robots fall. Is that F-45's robotics or is that F-48 exoskeletons? What's a wearable robot? So they'll meet with them. They have met with F-24, which is amusement parks, because robots are entering the amusement park industry.
Same.
Again, they're just asking the questions of like who has what. Um, and those cross pollinations can become real magical sometimes because you learn that maybe the amusement park industry has this law that really drives why they do certain things because there's this law in the books that they have to follow. So I know for mobile robots, we follow a lot of ADA because all buildings have to have ADA regulations.
Right.
Well, then that's
Yes.
something the robot has to be in compliance with. So
Right.
it's understanding all these different dynamics. And sometimes you have to reach outside of robotics to get your answer. And that's where some of the funnest stuff can always happen. Is when you reach into other expertise to
Right.
understand how you solve your problem. And through standards organizations, you can do that because you have all the industries together.
Gotcha. Okay. Well, that's excellent. I know we've run a little bit over time, so I don't want to hold everyone, including yourself. Aaron, thank you so much.
Mhm.
For everyone who was able to attend our call today, and for those who weren't, we will be able to post this recording on one of our FIT websites. So hopefully in the next 48 hours, you should receive an email with that. But if you do have any questions, please email me. Feel free to email me, rslotay@memphis.edu. With that, we thank you again, Aaron, and thanks everyone. Bye-bye.
Thank you.